Calculation number 1, molar gas constant in chapter 1. Calculate the molar gas constant R in the units of atmosphere, centimeter cube, per gram mole per degrees Kelvin. We start with ideal gas law. PV equals to nRT, where n is the number of moles of gas that would have a volume of V at pressure P and temperature T. Of course, temperature T should be expressed in absolute units of Kelvin or Rankine. Let's assume a basis of 1 gram mole of gas at a pressure of 1 atmosphere and temperature of 273 degrees Kelvin or 0 degrees Celsius. This amount of gas has got a volume of 22.4 liters. With this information, we are going to insert numbers in order to calculate R. So R is equal to PV over NT, which is equal to pressure P, which is 1 atmosphere, volume 22.4 liters, over 1 gram mole of gas, over temperature of 273 degrees Kelvin. And because the units is in centimeter cube, we are going to convert 1 liter is 1000 centimeter cube. If we solve this for R, we will get R equal to 82.05 atmosphere centimeter cube per gram mole per degrees Kelvin. For part B, we use a basis of 1 pound mole, and we know that 1 pound mole of gas is 359 foot cube at a pressure of 1 atmosphere or 14.7 psia and a temperature of 32 degrees Fahrenheit or 492 Rankine. Solving for R equals to PV over NT equals to pressure of 14.7 psia, volume of 359 cubic feet divided by 1 pound mole of gas divided by a temperature of 492 degrees Rankine. We solve for R and we will get R equal to 10.73 psia foot cube over pound mole degrees Rankine. In part C, we will do similar. R equal to 1 atmosphere of pressure multiplied by 359 foot cube divided by 1 pound mole of gas divided by 273 degrees Kelvin. 273 degrees Kelvin is 0 degrees Celsius or 32 degrees Fahrenheit. Therefore, R is equal to 1.315 atmosphere foot cube over pound mole degrees Kelvin. For part D, we will use the value of R calculated earlier in part B as 10.73 pound force over inch square which is the same as PSIA, foot cube over pound mole degrees Rankine. This is the value of R we calculated in part B. We will convert the inch square to foot square, 144 inch square over 1 foot square. And then we will convert pound foot to kilowatt hour. We know that 1 foot pound force is equivalent to 3.77 times 10 to minus 7 kilowatt hour. Solving for this, R will be equal to 5.83 times 10 to the minus 4 kilowatt hour over pound mole degrees Rankine. For part E, we convert what we obtained in D as 5.83 times 10 to minus 4 kilowatt hour over pound mole degrees Rankine. We just need to convert horsepower hour to kilowatt hour. We know that 1 horsepower hour is equivalent to 0.746 kilowatt hour, and solving for R equals to 7.82 times 10 to minus 4 horsepower hour over pound mole degrees Rankine. For F, let's use the basis of 1 gram mole of gas at 1 atmosphere or 101.325 kilopascal. R is equal to 101.325 kilopascal of pressure times volume of 22.4 liter divided by 1 gram mole divided by 273 degrees Kelvin, and we need to convert liter to meter cube. 1 meter cube is equivalent to 1000 liter, and we need to convert gram and kilogram. So 1000 gram is 1 kilogram. Solving for R, we get 8.31 kilopascal meter cube over kilogram mole degrees Kelvin. Finally, for part G, we will use the value of R obtained in part E. R was equal to 7.82 times 10 to the minus 4 horsepower hour divided by pound mole degrees Rankine. We will convert 1 horsepower hour to calorie, 6.4162 times 10 to the 5 calorie, and then we convert gram mole and pound mole. 1 pound mole is equivalent to 453.6 gram mole, and also we convert Rankine, 1.8 degrees Rankine equivalent to 1 Kelvin. R would be equal to 1.99 calorie per gram mole degrees Kelvin.